Okay. Good afternoon. Thank you, everybody, for attending our presentations. I'd like to start off by I have this as my screen, but if it's okay, I'm going to go with another screen of mine to start off with my presentation. So as mentioned, good afternoon, everybody. My name is Isaiah Torres. I'm a fourth-year biology major. My faculty mentor was Professor Christopher Clark from the Department of Biology. And the title of my presentation for today is Determining the Hearing Range of Hummingbirds. So I'd like to first start off with a quick introduction. So there haven't been many studies that have focused on determining the hearing range of hummingbirds. Back in 2004, Carolyn Pite conducted a study on a species of hummingbird known as the blue-throated hummingbird, because that hummingbird has been recorded producing ultrasonic sounds, or sounds that reach up to 50 kilohertz. And a couple years ago in 2020, authors Duque and al. Also published a study with another species of hummingbird known as the hailstar Ecuadorian hummingbird, because that hummingbird also has been recorded producing high frequency sounds, specifically 13.4 kilohertz. Now, the reason why these two hummingbirds were the subjects of these two experiments is because in the same year of 2004, in a book titled Nature's Music, The Science of Birdsong, Robert Dooling claimed that the hearing range of birds falls from 2 to 8 kilohertz. And as you guys could tell, 13.4 kilohertz and 50 kilohertz substantially exceeds that upper bound of 8 kilohertz. So the purpose of these two experiments was basically to determine whether these hummingbirds can hear the sounds that they produce. So I wanted my presentation to focus on a specific hummingbird and determining its hearing range. And the hummingbird that I chose was a female Cossus hummingbird, or which you guys could see currently on the screen. Now, my faculty mentor and another author, Catherine E. Johnson, also did a study in which they focused on a male Cossus hummingbird, and the results showed that male Costa hummingbirds produce sounds that range from 4 to 10 kilohertz. So later on, when I talk about a few aspects of my experiment, these two frequencies were taken into consideration. So my research question was, what can hummingbirds hear? Or specifically, what can this female Casa hummingbird hear? And my hypothesis entering into my trials was that the hummingbird would have a larger hearing range than 2 to 8 kilohertz. When reading the paper of Duque et al., there was a statement that was found within the paper that really caught my attention and really influenced my hypothesis entering into my trials. And it was this: if these hummingbirds are capable and produce such high frequency sounds, their intended receiver, which most likely is another hummingbird, has to be able to detect the sound in order to respond to it. And for that reason, my hypothesis before starting any trials was that the hummingbird would have a larger hearing range than 2 to 8 kilohertz. So seen currently on the screen is a quick schematic of the experiment that I had. As you guys could see, the female hummingbird was located next to a male hummingbird, but I want to focus on 3 circles that you guys can see within the cage of the female hummingbird. And those 3 circles represented the 3 locations that made up my experiment. Now, each of the circles had 3 things attached to it. It had an MP3 player, it had a speaker, and then it had a feeder. And then specifically with the feeder, it either had one of 2 options. It either contained a saltwater solution that the hummingbird did not like, to say the least, or it contained a sugar water solution that the hummingbird did like. And the idea of my experiment was to wait for the hummingbird to make an attempt at finding the sugared water reward, or the sugared water solution, also known as the reward. And after the hummingbird made an attempt at trying to find the reward, I would move together the speaker that would be playing a sound of a specific frequency along with the reward, and I would move that to another location and wait for the hummingbird to make another attempt at finding the sugared water. And I would continue doing that for a total of 33 trials for a specific frequency. And after that, I would conduct a chi-square test to get some statistical results. And from there, I would move on to another frequency. Now, in regards to the 4 frequencies that I use for my experiment, they are the ones shown on the screen. So I used a frequency of 200 hertz, 4 kilohertz, 10 kilohertz, and 14 kilohertz. And as I mentioned, each frequency block consisted of the hummingbird trying to find the reward 33 times, or 33 trials. But before I could start any trials using sound, I had to conduct what's known as negative control trials, which was basically 33 trials in which all 3 of the locations were set up the same, but none of the speakers were on and none of the speakers were playing a sound. And the idea to the negative control trials was just to ensure that there was nothing within the locations of the experiment that could positively influence or give like a upper hand for the hummingbird at finding the reward. And the what was expected, or what I needed to obtain from the negative control trials in order for me to proceed with my trials using different sounds, was to receive an insignificant results from the chi-square test. Now, in the next couple of slides, we'll talk about what an insignificant results means, and how it was calculated. But as it pertains to right now, I started with 33 negative control trials, and then from there followed that up with 4 different frequency blocks. So here were the results that I obtained from my experiment. But as it pertains to today's presentation, we're just going to focus on a specific frequency, and we're going to analyze the chi-square test. I want to mention that each of these screenshots are a screenshot of the chi-square test and the results that were calculated for each frequency block. So for today, we're going to focus specifically on the 4 kilohertz trials, and we're going to just go through each of the components of the chi-square test, kind of talk about what each of the information means and how the results were calculated and how I analyze and how I perceive the results that I obtained. So starting off with the first row, the expected, which is highlighted in green. As it sounds like, the expected represented the expected results in nature. So if you guys remember, I mentioned that there's 3 locations, with only one of the locations having the sugar water reward. So naturally, with no outside help, the hummingbird would have a 1 in 3 chance of approaching the correct location the first time, which gives us a success rate of 33%. So if I modify that to a total of 33 trials, that would mean that the hummingbird would arrive to the correct reward location 11 times out of those 33 total trials. Now, this first row, the expected, was the same for each of the frequency blocks, including the negative control trials. If we move on to the observed, which is currently highlighted in purple, the observed represented the data that I collected from the experiment of those 33 trials. So knowing that currently we're viewing the chi-square test of the trials using a sound of 4 kilohertz, we could see here that the hummingbird arrived to the correct reward location 21 times out of the total 33 trials. So once this information was inputted, once the information was inputted, a p-value was returned back to me, and it was based off this p-value whether or not the results could be deemed significant or insignificant. So I'd like to first start off with the significant, which we could see currently right now in the blue text. So a significant result would be an instance in which the p-value returned back to me would be less than 0.05. So as we could see for the 4 kilohertz trials, the p-value returned back to me was 0.01. Now, a significant result allowed me to statistically come to the conclusion that the speaker that was playing the sound positively influenced the hummingbird's path to finding the correct reward location, and thus allowed her to have a greater success rate. And as I mentioned earlier, I needed to obtain an insignificant result from my negative control trials before I could proceed with the rest of my experiment. Now, an insignificant result would be an instance in which the p-value returned back to me would be greater than 0.05. And I would be able to statistically conclude from an insignificant result that the speaker had no positive effect on the hummingbird and her success rate when approaching the correct reward location. And the reason why it was necessary for the negative control trials is because, if you guys remember, I mentioned that none of the speakers were playing sound. So if my results were returned back to me significant, that would kind of give me the red flag that there was something within the experiment and the locations that was giving the hummingbird a greater success rate at finding the reward. So that's why it was important that I received the insignificant result for the negative control trials. So as you guys can see with this handwritten graph, I want to first focus on the frequency blocks. And as we can see on the graph, the success rate that was obtained for each of the frequency blocks was almost double that of the 33% success rate, or the baseline success rate. And that was largely contributed by the speaker playing the sound. Now, I want to focus, and I want to take a couple moments to focus on the negative control trial success rate. As you guys could tell, I received a success rate of 39%, which is 6% higher than the normal 33%. This is where the importance of the chi-square test had in my experiment, because even though I obtained that 39% success rate, once I inputted that information into the chi-square test, and I received that insignificant result, I was able to conclude that there was nothing within the location that was giving the hummingbird an extra advantage. So even though there was that 6% discrepancy, there was nothing that I needed to worry about. And from there, that's why I was able to proceed with my frequency block trials and finish with my experiment. So those were my results obtained. So in conclusion, here were the two conclusions that I came up with. The main conclusion is that the hearing range of hummingbirds is 200 hertz to 14 kilohertz. If you guys remember, I mentioned in the beginning that my faculty mentor and another author focused on the male costless hummingbirds and how they produce songs that range from 4 to 10 kilohertz. So knowing that the hummingbird can hear frequencies that range from 200 hertz to 14 kilohertz, I was able to come to the conclusion that the costless hummingbirds can hear their own sounds. And a minor conclusion was that the hummingbird was able to learn that the location of the sound indicated the location of the reward. So that just meant that once the speaker, as a speaker was playing that sound, the hummingbird was able to associate the location of where the speaker was playing sound to the location of the reward. And I was able to come to that conclusion based off the substantial increase in success rate from the hummingbird when there was a speaker playing a specific frequency. So here are a few anticipated questions that you might have thought of during my experiment, and I'll just go through the questions real fast. So the first one is, why did 3 of the frequency blocks have the exact same success rate? So if you guys noticed, some of the 3 of the frequency blocks had a success rate of 64%. In regards to how the results ended up occurring that way, they just occurred that way. So that's the answer to the first question. The second question is, what other experiments can arise from the findings of this experiment or from my experiment? Honestly, there are many angles that a future experimenter can improve and can stem from this experiment. But one example could be just experimenting with even lower or higher frequencies. I mean, when I was in the process of determining which frequencies I wanted to use, as I mentioned, I took in consideration the frequencies from my faculty mentor study. But other than that, I just chose, along with my faculty mentor, with our collaboration, I just chose 4 frequencies. So a future experimenter could try a frequency that's lower than 200 hertz and higher than 14 kilohertz, and see if the hummingbird could hear those sounds as well. In regards to the female hummingbird, now that I have finished what's going to happen to her, now that I have finished with my trials, she will be released soon. And then fourth, how enjoyable was this experiment in its entirety? It was very fun, and it was very cool. It was a really interesting process and experience for me. As I mentioned in the introduction, there really haven't been many studies that have focused on hummingbirds and determining their hearing range. So I knew that my project would be kind of unique in that aspect. And since the beginning, I was really interested, and I was really excited to just go through the whole experiment and get my results, and just be able to have that experience with the hummingbird and determine ultimately its hearing range. So I'd like to thank you guys for your attention today, and I will take any of you guys' questions at this moment.